Hello everyone, welcome to Entri. Hope you all know about our AE and AEE courses. So power system. So today what we are going to discuss is the power system, how to score good marks, and with that I will give you some of the inputs also in subjects. So not only power system, okay, so how to prepare for the other subjects also, like basic idea I will be providing for all those things, and some power system concepts also we will be knowing from this. Okay, so anyway, so in this session what we are going to study is a concept only, but before that I will give you some basic idea about entire power system network. So I am calling power system as power system network. Okay, so good afternoon everyone. So what we are going to discuss is the power system concepts only, but before that I will give you clear idea about entire power system. Okay, so let's take power systems means what is the basic syllabus we need to know means the first one is our power system generation. Okay, so let's take power system generation. Okay, so remember something, all the syllabus I will give you clear idea, then you can get a clear cut idea about where you will get the marks, where you will get the good marks and all. Okay, so first we need to discuss about the entire syllabus first. Okay, so just maybe 5 or 6 minutes we will discuss about this. So let's take once. Okay, so first what we need to know, so power system generation or power generation I will write down. Okay, so power generation. Okay, so most of the people you may know about these concepts. In power system generation, what are the things present you may know already, understanding, right? What are the things present and what we need to study, you have to know all those things. Okay, so power generation through hydel, that means hydroelectric power station. Okay, so hydroelectric power generating station you have to know. In that many bits will be there. Okay, I am not giving the bits at a time now, so we will just give clear idea. Okay, so there will be definitely some bits from hydroelectric power station. Okay, and next one is thermal power station or thermal power. Okay, so thermal or steam we can call. Okay, so thermal power station. Okay, so thermal power plant we can write down or power station, anything. Okay, so thermal power station, hydroelectric power station, there are many components like economizers are there, air preheaters are there, there will be flue gases. You might have remember already these all names. Okay, in the exam they will concentrate only on these things only. Okay, they will definitely concentrate on each and every important bits from these. Okay, definitely without these two unit bits. Okay, so there will not be any question paper. You take your Genco, Transco exam, any AE or AW exam, go for any metro exam also. Okay, so if that is electrical powers, if in that exam electrical power system is there means definitely they will concentrate on these things definitely. Okay, so remember 2 or 3 bits they will ask directly. Okay, and one more thing I want to tell you, those are previous bits only. Okay, so whatever they will be giving from this, they will be already given in the previous years. Okay, so that's why previous year bits you need to solve. Okay, so next one is what is that power plant we need to know means that is nuclear power plant. Okay, so our nuclear power station we can call. Okay, so nuclear power plant. In generation these are the major things. Okay, so these are the major things we have. So this session for triply, this is the session for electrical students only. Okay, so if you are from ECE, so this subject is not present for you. Okay, this power system subject is just like your communication subject. So electrical students will not study communications, and similarly power systems will not be studied by ECE students. Okay, so like that. And there are some common subjects you may know. Okay, so networks is the common subject, measurements is the common subject, not measurement in some exams. Okay, so measurement is also common subject. Control systems is also included in some of the exams. Okay, microprocessors, digital electronics, analog electronics, signals and systems. Okay, if you go through the syllabus of entire different type of exams whatever we have, so you will understand. Okay, so there will be many common subjects we have for electrical and ECE and if something is useful for your exam, then you can definitely prepare from our things. Okay, so anyway, nuclear power plant. Okay, so and remember, this is very important concept, very simple concept also. Okay, so very simple and very important concept also. Never leave any question from this. Okay, so that's what my suggestion. Simple bit will be there. Okay, prepare for 1 hour, just 1 hour. You watch the video of our lectures, 1 hour you watch this. So that's enough. Okay, all the type of bits will be covered. Okay, so that's what, understood, right? So these are the major concepts in power system generation, and moreover you have some more things also in power system generation. Those are nothing but, so gas power stations. Okay, so gas power plant or diesel power plant, or we have some different type of power generating station, tidal energy. So from the tides also you can generate the power, right? Okay, so that's also is there. Geothermal energy, or there are many other concepts also. We don't need to study all those things. Okay, so if you want, you just need to understand. So the gas and diesel power plants, that's enough. Okay, so these two are enough. So and these three, okay, so we should never leave a question. Okay, so these are definitely questions, and those are all definitely 4 or 5 marks you will be getting if it is a Genco exam or even your Transco exam also. Okay, so any AE or AEE, never leave questions from this one. I will tell you, okay, what model of questions in soon. Some more sessions also will be there, right? Okay, so in those we will be discussing some questions also from these things. Okay, what we have to know today, that concept is different, so that's why I will not go in deep now. So soon you will be understanding about this all in deep. Okay, so I will explain those things. Okay, anyway, so this is the power generation concept. You have generated the power, right? So will you connect directly to the load centers? So can you, otherwise your home is there, you need some power supply, right? So will you directly connect to the generating station? It's not possible, right? What you will do, first you will generate the power. That power you will take to some power grid. After that you have to transform. Okay, so that means transmission has to be started, and that transmission of power, okay, where it will be going, transmission. So it will reach different locations all over the places. Okay, wherever you need some power supply, so everywhere you will be taking that power, and after that power distribution will be happening. Okay, so anyway, let me give some general idea. Okay, so let me take this one as a generating station where some generator is there. Okay, so generator. So what is the generating voltage? What is the generating voltage in India? So we have hydroelectric power stations, thermal power stations, and nuclear power stations. Okay, these are the major type of power stations. And in India, what are the major things means? Hydroelectric and thermal power plants. So these are the things. Okay, so these two are, we have many. Okay, so these we have many. Okay, understanding, right? Okay, so many we have, so that's why these will decide what is the generating voltage in India. So understand, according to some constraints. Okay, so it will be 11 kV of generation. Okay, so 11 kV generating voltage. Whenever 11 kV generated, then directly, do we have any 11 kV loads for us? We don't have any 11 kV loads. Understanding, right? We don't have any 11 kV loads. So what we need to do? We need to change this voltage. We need to change this voltage to our load voltages. Okay, so that means we have to step up the voltages or step down the voltages according to the requirement. Understanding, right? But you see, load center is not this much near, right? It will be hundreds of kilometers. Your home, so let's take Sri Salem project is there. Okay, hydroelectric power station we have. Okay, where is our home? Maybe 100 kilometers, or some people 200 kilometers, some people 500 kilometers. So we are all load centers. We need power supply from there. So how it's possible? We need to, the power transmission has to be done, right? Okay, from the generating station towards the load center, transmission has to happen. But which transmission? High voltage transmission or low voltage transmission? What you will be preferring? So that we need to understand some more points. Okay, I will tell you now. See, for example, power, total power is something whatever we have generated. If power means some voltage will be there and current will be there, some power factor also there. But just now understand, voltage and current. Okay, if voltage is more, current is less, because whatever power you are generating here, so that will be constant. Okay, every day you will generate 100 megawatt from this generator, for example. Okay, so that means voltage and currents, they will be based on this power, how much power you have generated. For example, if you prefer high voltage transmission, if you are preferring, then that means current is less. Whenever current is less, the area of cross section of the conductor, it will be less. Because so if you need more current to flow through this transmission line, okay, so let's take this as the transmission line. If more current has to go through this transmission line, then more area of cross section is required. Okay, so this is in the design stage only, I will tell you. Okay, so in deep we have to know about these things. Later in other concept I will explain for you. Okay, so remember, if more current has to go through this transmission line, then more area of cross section it should have. Okay, that means outside whatever wires we are seeing, transmission lines we are seeing, if instead of high voltage, high current it is, then more cross sectional area it will be. Understanding, right? So this session is for any electrical students. Okay, whoever wants to know about power system concept and how to prepare for power system, so they can understand from this session. Okay, so even for GATE also, even for engineering services also. But so questions we are not discussing directly here. Okay, I will not give you the questions now in this session, but clear cut idea about entire power system I will tell you. Okay, so because you may know one thing. Okay, so we need to study about GMD GMR concept, we need to study about underground cables, we need to study about our generation concepts like nuclear power plant we need to study. So why we need to study, what we need to study, we don't know exactly. Understood, right? Even we don't have any guidance at the beginning. One by one, once you study one, then only you will understand. Okay, so what is the importance of that concept, how much deep you need to understand that. Okay, I will give you all those ideas. Okay, any electrical students, if you have any doubt in power systems, or if you want to know more about the power system concepts, then I will explain. Okay, so don't fix this one as your Genco or Transco exam only. Even you can write any exam in India. Okay, so with the same power system concept only, we have DRDO exams, ISRO exams we have, BARC exams we have, and Singareni exams we have in Telangana state especially, and there are many. Okay, so many nuclear power, and some other exams also are there. Okay, so these all things you can apply if you know the power systems. Then if you have power system subject in that syllabus, then you can definitely understand from this session. That's it. Okay, for Genco and Transco especially, it will be more useful. Okay, so that's what my idea. Understood, right? So anyway, if more current flow has to be there in the transmission line, then more cross section area. That's why outside, if more power has to transfer through that, more thickness of the wire, that means sag will increase. If more thick wire is there, okay, so from this pole to that pole, more thick wire is there, because weight of the wire is more, right, it will come down. Okay, sag will increase. That's why it's not a good thing. Okay, and moreover, more material is required for this wire. More material, right, from this pole to other pole, more material is required for this wire. That's why more costly it is. Okay, so that's why high current transmission we will not do, high voltage transmission we will do. Understanding, right? So what we need to do is this 11 kV we have to step up. Okay, so step up means we have to use some transformer, step up that voltage to 400 kV. 400 kV means why only 400 kV? Because power grid works at 400 kV. Okay, so power grid is also a substation. Okay, so power grid is also a substation where it will be power, whatever power it has received from the generator, it will be transmitted to the other centers. Okay, so I will tell you how it is. From here, so there will be stepping down of voltage. Okay, so like there are many other voltages. Okay, so I will tell you. So many other voltages also present. So what are the other voltages? After 440 kV, we have 220 kV. Okay, so 220 kV we can step down if you want. Okay, if we have 220 kV load, then you can step down that voltage to 220 kV. Okay, and we have 138 kV. and we have 90 kV, okay, otherwise 90 kV nowadays we are not using perfectly in some example, in some applications, that's why 66 kV, okay. So then we have 33 kV, okay. So these are all the things, okay. So different voltages. After that 11 kV we have up to here the transmission, okay. So entire transmission, okay. So understand, whatever we have generated this power, we have to transmit to the load centers. So that's what our aim now. But how? There is a transmission line we need. Just think once, you have only generators now, okay. You have only generators. You don't have any transmission lines. You have to construct this, you have to install this transmission line. How to install this transmission line? Understand how to install this transmission line? We need what material we are using for the transmission line. And similarly, what is the type of transmission line, type of the conductors we have, okay. You may know already, okay. ACSR type of conductors we are using. So if you have attended the last live, okay, then you will understand. I have explained why we are using ACSR type of transmission line model, okay. That means conductors, ACSR type of conductors, why we are using, we can get that. Understood, right? So that means transmission line concepts we need to know, okay. So transmission line concepts we need to know. So that's why power system transmission also we need to know, okay. So let me give clear idea, okay. So power transmission also we need to understand, okay. So power transmission, okay. So in power transmission, what you will be knowing means the basics, many basics you will understand, okay. So what is the material we are using for the transmission line? Generally you can answer, okay. So what is the material we are using? That is aluminum material we are using, right, okay. There are many other materials like copper material we have, aluminum material we have, gold material we have, and we have silver also, okay. So everything we can use, but what we have choose? We have choose aluminum material, okay. So for the transformer windings we are using copper windings, and for the transmission lines we are using aluminum conductors. So why there is some difference? You will understand deep, okay. So these are all the bits they will be asking. Whatever I am creating some doubts for you, the same things only they will ask in the exam also, okay. So if you have any doubt, otherwise if any problem is there to understand something, you can message in the chat box, okay. I will be continuously monitoring. I will tell you, okay, so about what it is. Understood, right? So anyway, just see. So basics, okay. So basics of transmission lines we need to know. After that, so there will be GMD and GMR calculations. Do you know about this one? GMD and GMR, okay. So GMD and GMR calculations, okay, of the transmission line, okay. So I will explain these all now, okay. So after some time I will explain about GMD and GMR calculations only. So after GMD and GMR calculations, you will know about representation of transmission line as per phase model, okay. So we will represent as per phase model. Why we need to represent the transmission line as per phase model? Understand? So we have outside, right, okay. So outside we have transmission lines. So every transmission line we may not be understanding, we may not be analyzing on the paper. That's why what we do is, for the entire transmission system, we will make some per phase model, okay. So that means a per phase analysis, like phase to neutral analysis we will be doing. From that you will get the many operating parameters, okay. So like what is the sag in that system, what is the, so there will be some of the losses also in that, right, okay. Skin effect will be there, and many other things also there, right, okay. So that's all things you can understand once you can represent per phase model of that transmission line, okay. So after that you have to represent efficiency and voltage regulation of the transmission line, okay. These are like performance indices, okay. So performance indices, every system, okay. So every system, after designing, what you need to do, you need to check that performance. Understood, right? What are the things we need to check for the transmission line means, one will be efficiency, another one will be voltage regulation, okay. So you understood, right? So I will explain, okay, after some time one by one, okay. So and after that we need to model the transmission line as long line, okay, medium line, Okay, so after that long line, medium line and short line. Okay, so these are the analysis we need to do. Okay, so long, medium and short line analysis. Okay, so these all things we need to understand. Okay, so that's what about the transmission concepts actually. But after doing that, once you analyze long line, medium line, short line analysis, so we need to check, right? So efficiency and voltage regulation. So voltage regulation, how you can check? So we need to know about what is the line drop, okay, in the transmission line, what is the voltage drop, that we need to understand. Okay, so that's why, so if the voltage at the receiving end side, okay, you are using your load at the load center for our load, okay, for our light or fan, anything, if you get low voltage, will that work properly? It won't work properly, right? Okay, so what we need to do, we have to improve that voltage from low voltage to actual voltage. Understanding, right? Similarly, if we had over voltage, there are many over voltage in the system, right? Whenever some lightning occurs, okay, so lightning means, so from the cloud, okay, so there will be surge coming and it will hit the transmission line. So definitely, so some extra voltage will be generated, extra voltage will be coming on the transmission lines. That is nothing but over voltage for us, lightning over voltage. So because of that, our loads will damage immediately. Getting right? Okay, so that means, so how to understand these over voltages, how to overcome these over voltage effects. And there are switching over voltage also in the system. So there may be possibility, whenever you turn on the switch, whenever you turn off the switch, there may be possibility of spark, you might have observed. So that is nothing but over voltage only. Because of that, in the transmission line, there will be little bit more over voltage. Because of that, some of the loads may get affected. So that's why whenever you get the over voltage, you have to bring back that over voltage to normal voltage. Understanding, right? Whenever over voltage is there, that you have to bring back to normal voltage. Whenever low voltage is there, you have to bring back that normal voltage to, so bring back that voltage to normal voltage. Understanding, right? So that's what about, okay, so let's understand. Okay, I might have removed that, so let's see. Okay, so there will be over voltages and under voltages. So what we need to do, we need to check the voltage profile. Okay, it's just a continuation. Okay, so voltage control we need to know. Okay, so voltage control we need to know. Okay, so in voltage control, what you will be knowing? Okay, how long will be the webinar going on? So webinar will be for 1 hour or more, that's it. Okay, so this webinar is 1 hour or more only. You can ask me some doubts if you want. Okay, so most probably your preparation strategies or any of your power system concepts, how you want to know, those all you can ask me in this 1 hour only. Okay, I will explain. I will be continuously monitoring the screen here, another screen. So I will explain you. Okay, so how to prepare in the power system. Okay, in the power system, or if you want to know about some other subjects also, I will tell you. Okay, so let me give some idea about this entire syllabus for 2 or 3 more minutes, then you can get. Okay, so after voltage control, what we need to study is the insulators we have to study. Okay, so insulators we need to study. So later underground cables we need to know. Okay, underground cables. So later distribution systems we need to know. Okay, so distribution, so transmission, this all parts come, this all whatever we have discussed previously, so this all comes under the transmission concept. And this one, okay, so this one is distribution is separate. Okay, in distribution we have different distribution models like radial distribution system, ring main distribution system and interconnected distribution system. So they may give some questions from this distribution also. It may not be that so important for us. I will explain. Okay, so in other sessions this one. Okay, understanding, right? So anyway, this is all about the transmission and distribution concept, and that's what power system transmission. Okay, power transmission it is. And later we have our power system analysis. Okay, so power system analysis we need to do. So in power system analysis, so you will be knowing about per unit studies. Okay, so per unit analysis we will study. Okay, so per unit analysis. Okay, so after per unit analysis, actually why we are doing this per unit analysis means to represent the system entire system to represent as a single line, we need per unit analysis. Okay, in per unit analysis you are getting some advantages, that's why we are giving this per unit analysis. Okay, so once you study about per unit analysis, then you will study about fault analysis. Okay, so fault analysis, then you will study about the stability of the entire power system network, whether see suddenly load may increase or load may decrease, our system has to be stable, right? Okay, just like on any system, on a bus, otherwise on a generator, so there will be more load, that means more burden on that generator, for example, then generator may fail. Once generator fail, not only that generator, that whatever it is giving power, it will not give now, so other generator will feel more burden, so that means all the generators will feel some burden at that time, whether the system is stable or not. If you increase the load or decrease the load, generator has to be stable only. And similarly, you increase the input, water input you increase to generator. If it is a hydroelectric power station, we are using the turbines, right? Okay, Pelton wheel turbine or Francis turbine or Kaplan turbine, propeller turbine. So according to the requirement, we will use this type of turbines. So whenever water input if you increase, then generator will try to rotate with more speed, right? It should not rotate with more speed. Understanding, right? It should not rotate with more speed. It has to rotate because synchronous machines we are using everywhere, in hydroelectric power station or in thermal power station we are using synchronous machines, right? Okay, they have to rotate at constant speed only. So even though the load increases or load decreases, our input increases or input decreases, machine has to run at constant speed only, then only generation is possible. Understood, right? That's why you have to study stability analysis. Okay, so this is stability analysis you need to know. Okay, so how to prepare for ESET for W branch students. Okay, so ESET W branch means, so whatever these concepts are not there. Okay, so just whatever previously transmission and distribution is there, so up to there only for ESET it is there. Okay, so but for the ESET students, okay, so power system analysis concept is not there, and power system protection is also present. Okay, just 1 minute I will talk about ESET. So there will be generation concept and power transmission and distribution concepts, then we have protection concepts only. Up to here only we have for ESET. Okay, and for ESET you need to do previous year questions. Okay, if there is any availability of previous year book for the power systems, networks, measurements and machines. Okay, just prepare all these things, and even digital and analog electronic questions you will get simple only, but other questions like power systems, machines, measurements and electric circuits. Okay, so these things you just need to do the previous year questions, everything will be covered. Okay, almost 90% of the questions from ESET you can cover if you prepare for that. Okay, so just as the information I have given. Okay, so but if you know about these all things, okay, so then you can prepare for even AE and AW also. These concepts are very vast. Okay, so many bits will be coming from this, many, almost like in power systems, for example, in some exam 100 questions are coming for example. Okay, just to explain you, I have taken 100, no exam will give 100 questions, we know already. So in, for example, 100 questions are there, almost 40 questions are from power system analysis only, and almost 70 questions, okay, 70, total of 70 questions are from power system analysis and power transmission and distribution only. Okay, so these are things we need to know. Understood, right? Okay, so that's what. Okay, so this is the stability. After that we need to know about Y bus and Z bus analysis. Okay, so Y bus and Z bus analysis. Okay, so these all things we have to know from this power system analysis. Okay, so we have power system protection concepts. Okay, so we have protection concepts also. So power system protection. Okay, so in protection what we need to know, we have only two concepts. Okay, two things we have to know. First one is relays. Okay, so first one, different type of relays we have. After that we have different type of circuit breakers. Later we have different protection schemes, okay. For the generator some protection scheme, for the transmission line some protection scheme, for the transformer some protection scheme, like that. For different devices we have different protection schemes, those you need to know from this protection, okay. So anyway, after this we have utilization of energy also, there will be some tariff calculation and drives also, we need to know about those all things. But now in power system actually up to here only we will be studying as the complete one, okay. So but in this session what I will discuss with you means, so the GMD and GMR calculations and representation of our transmission line as per phase model, okay. So I will discuss about these all things, okay. So electrical equivalent circuit of three phase transmission line, okay. Electrical equivalent circuit of three phase transmission line, how to represent that, okay. I will discuss those things, okay. See, for example, if we have a three phase system, okay, so a three phase system is there, you might have observed like this, okay. So three conductors we have, just think once, if I am the pole, okay, if I am the transmission pole, so then there will be some cross arm, right, okay. Cross arm means where you will place some insulator on this. Can you imagine this? Just understand, okay. If you can't understand, just message there in chat box, okay. You can ask in Telugu also, there is no problem, okay. I can understand, okay. So on the cross arm there will be insulators, you might have observed outside of this in the street also, okay. So on the cross arm there will be some insulator like this. First conductor will go like this, second conductor and third conductor. I have just given those three only, okay. And remaining I have, see, this is the cross arm here. On the cross arm there will be insulators, on the insulator there will be some conductor, okay. You can get that point, right, okay. Gate, okay. So for gate you need to do all the things, okay, like transmission, distribution, and so for the gate, okay, if you want to prepare, so for the gate exam, transmission and distribution and power system analysis, okay. So these two you need to concentrate more, but from the protection concept on also you can get one bit, and from the generation also you can get one bit, and economic load dispatch is also there, okay. From that also you may get one bit, okay. So that's what for the gate, okay. But for the gate most probably theoretical questions will not be there much, okay. Most probably conceptual questions, otherwise everything is numerical problems only, okay. So all the numericals only they will give for gate, okay. Anyway, whatever I explain GMD and GMR calculations, this is present even for the gate also, okay. So whatever concept I am discussing for the next half an hour, it will be useful for gate exam, even for the engineering services exam. You can write any exam which is in power system, okay. But in some exams this syllabus is not present, so that is for E-set, okay. E-set only the basic analysis is present, okay. That is not a competitive level exam, that is recruiting type, okay. Just to join in some engineering colleges you need to write the E-set, right, okay, after the diploma. So that's what, okay. Anyway, this concept little bit required for the E-set, okay. That's it, understanding, right? So anyway, so electrical equivalent of, okay, three phase transmission line, okay. So this is A phase, this is B phase, this is C phase, okay. That means it is a three phase system, right, okay. So three phase system. So if you get doubt you can ask anytime, okay, remember. So this is what you will prefer, a balanced power supply or unbalanced power supply. Think once, okay. What you want to transfer, power, a balanced power or unbalanced power, what you will prefer? Unknown answer, we all know balanced one is the good one, okay, because there will not be any change in operation for all the different things, okay. That's why balanced power only will transfer every time, okay. So remember, through the transmission lines every time you are preferring a balanced power only. That means how much is the power in A phase, that much only in the power in the B phase, same power in the C phase, that's it. Understanding, right? How much current flow in this, same current flow, but this is a three phase system, right? So definitely I am just giving I at an angle of 0 current, I at an angle of minus 120 current, and I at an angle of minus 240 current, okay. So those are the three currents, understanding, right? But you see, as current in this one, magnitude of current in this one, magnitude of current in this one, magnitude of current in this one, all are same only, right? So definitely If more current, more area of cross section, less current, less area of cross section. You know this point, right? I have already mentioned. So that means as all the magnitudes of currents it is same, so radius it will be same only. Okay, so radius of the conductor it will be same. Okay, so if you want, I will tell you what is the material we are using for this conductor. That is nothing but aluminum conductor. Okay, so material we are using as aluminum conductor. Okay, and what are the types of conductors means, that is, if here we are using solid conductor system. Okay, for the explanation I am just taking solid conductor system. That means this is solid conductor. Okay, so instead of like that, if you use like this, okay, so this is nothing but our stranded conductor system. Okay, and instead of same type in middle one, if we have different one, so this is like composite stranded conductors. Okay, so composite stranded conductors. Anyway, solid conductor system we are using here. I am not explaining about. So these all things. Okay, so what we are using actually in outside, that is nothing but ACSR type of conductors. You understood, right? ACSR type of conductors. ACSR means aluminum conductors with steel reinforcement. Understanding, right? Aluminum conductors with steel reinforcement. Okay, so anyway, current going in this one is same, current going in this one, all the three is same, so area of cross section is also same only. Understanding, right? So whenever the area of cross section is same and current flowing is also same, the flux linkages in the first conductor, flux linkage on the second conductor, flux linkage on the third conductor are same only. Okay, you just see one thing I will ask you. Okay, so the radius is same only, but distance from here to here is x. I will consider distance from here to here, it is nothing but y. I will consider distance from here to here, I will consider as z. Are you understanding? Distances. Okay, so there will be some distance, right? But you see, for the A phase, whatever flux linkages, magnetic flux linkages are there, so it may link with B also. Those are mutual linkages. Okay, can you confirm that? Whenever in a current carrying conductor, definitely there will be some flux linkages producing. Okay, magnetic flux linkages on the conductor. Okay, some of the linkages will link with the same conductor and some of the linkages will link with the other conductors. Okay, so that means you just understand again. See, if I am the conductor, okay, so if some current flows through this conductor, so definitely some magnetic flux will be produced around this conductor. If that magnetic flux link with the same conductor, then that is self linkages. Okay, and if these magnetic linkages will link with the other conductor, B conductor, that is nothing but mutual linkages. Okay, you understood, right? Mutual linkages those are. Got it, right? And similarly, these mutual linkages may link with C conductor also. Understand one thing, for the A conductor, whatever mutual linkages are there, so at x distance and x at z distance, because B phase is at x distance, C phase is at z distance. Understanding, right? Now similarly, for the B phase you take, what is the distances of A phase and C phase? One is at x distance, one is at y distance. Can you confirm one thing? For the A phase, how much is the mutual linkages, and same will be for the B phase also? For the A phase, how much will be the mutual linkages? Same will be for the B phase also? It's not same, because distances are different. For the A phase, B phase is at x distance, C phase is at z distance. But for the B phase, A phase is at x distance and C phase is at y distance only. So there is a difference in mutual linkages. This will decide the inductance of this phase and the inductance of this phase may vary. You understanding, right? So there is no constant. Okay, so for the A phase analysis is different, for the B phase analysis is different. Okay, because the self linkages and mutual linkages are different. Okay, so let's understand as different. Okay, so let's take this as the A phase, B phase and C phase. Okay, this is A, this is B, and this is C. Okay, so every phase will be having some inductance, right? Okay, so this is having LA, this is having LB, this is having LC, which is nothing but self inductance. Okay, self inductance of A phase, self inductance of B phase, self inductance of C phase. These may be same. Okay, these may be same, but mutual linkages. Okay, we need to see about mutual linkages. Okay, understanding, right? Mutual linkages we need to see. Between these two, distance is nothing but x, between these two, distance is nothing but y, and between these two, distance is nothing but z. Got it, right? So that means mutual linkages are not same. Okay, so like mutual inductance from A to B is not equal to mutual inductance from B to C is not equal to mutual inductance from C to A. Okay, we can confirm like that. That means whatever inductance of entire inductance of A phase, entire inductance of B phase, entire inductance of C phase, those are all not same. Okay, so not same. That means you have to analyze A phase separately, you have to analyze B phase separately, analyze C phase separately. You think once how many equations you require, more equations you need to analyze. Okay, so just see the సార్ ఏఈ అండ్ ఏడబ్ల్యూ పోస్ట్కి నోటిఫికేషన్ ఎప్పుడు చెప్పండి, ఎప్పుడు ఇస్తారు సార్ అంటే తొందరలోనే వచ్చే ఛాన్స్ ఉందని చెప్పేసి మాత్రం తెలుసు నాకు కూడా. సో మేము మా యాప్లో అప్డేట్ చేస్తాం ఈ విషయాలు కూడా. ఓకే, సో విల్ ఇన్ఫార్మ్ అబౌట్ ద నోటిఫికేషన్స్ అండ్ ఆల్. ఓకే, సో జస్ట్ సబ్స్క్రైబ్ టు దిస్, దెన్ యూ విల్ అండర్స్టాండ్. ఓకే, సో వెన్ ఎవర్ దెర్ ఈజ్ న్యూ నోటిఫికేషన్ or not only AE or AEE, so in Andhra Pradesh or Telangana, any electrical type of exams or any other exams you have, so we will be informing about those all things. Okay, so anyway, let's see, this is about the inductance only. For A phase, B phase and C phase, it's not same. Okay, once it is not same, A phase we have to analyze separately, B phase we have to analyze separately, and C phase also we have to analyze separately. Okay, it will take more time. Why you have to analyze the circuit, why you have to analyze the transmission line? Without analysis, how you will understand whether that is efficient or not, whether on that more voltage drop is there or less voltage drop is there, on the transmission line is there any corona loss, everything you have to know, right? So that's why per phase model you have to represent. Instead of representing as 3 different phases, we need to represent as a single per phase model. Okay, so that's why I have given per phase model representation. Okay, you understand? Not only inductance. Okay, so there will be capacitance also. So what is the requirement for the capacitance formation? How capacitance can be formed means between two points, if there is any voltage difference and they are less separable, that means very near. Understanding, right? So for example, okay, so between 2 points, if any voltage difference is present, and definitely between those two, okay, so between those two only very less distance must be present, then only capacitance will be formed. Okay, you observe here the voltage is nothing but V at an angle of 0, here the voltage is nothing but V at an angle of minus 120, here the voltage is minus 240, V at an angle of minus 240. Definitely there is some voltage difference between these two, not maximum voltage. Okay, so you observe this is the A phase voltage after 120 degree. Okay, so this is the 90, right? Okay, so 90 plus 30, 120. Okay, so after 120 degree there will be second phase. You take, okay, so this is A phase, this is B phase. You take any point. Okay, so let's take as at this point. Okay, at this point you will take, what is the voltage? Positive voltage, which is B phase voltage, and what is the voltage at this point? So that is nothing but a negative. Okay, so there will be some voltage difference and they are less distance. Okay, so distance between these two is x only. That means this capacitance between these two, okay, so capacitance between these two is some CAB for example. Okay, can you confirm capacitance CBC is the same as CAB? If x distance is equal to y distance, then only it will be same. Understanding, right? And similarly between these two also there will be some distance which is z, so that capacitance, okay, so CAC, it is also not same. Okay, so and similarly there will be some ground, right? So from the transmission line, okay, you see above overhead transmission line system, right? It is okay. From here, so towards the ground distance, whether it will be same or different, we need to know. Okay. For example, horizontal configuration. Horizontal configuration means this is the first one, this is the second conductor, and this is the third conductor. Okay. So this is horizontal configuration. What is vertical configuration means? Like all these things. First one here, first conductor here, second conductor here, and third conductor here. Okay. Bottom one will be near to the ground, and the next one will be at the middle, and the next one will be far from the ground. You can understand, right? Distance is varying, just like this. This is horizontal configuration. If we have wires like this, okay, you might have observed in the streets. Okay, so there will be vertical configuration. There will be vertical configuration also. Okay. So we can teach in Telugu or English, no problem. Okay. If it's okay, I will continue in this. Otherwise, in Telugu also. Okay. Maybe from other live also. But it's better to understand in English only. Why means you will get the points clearly. Okay. But explanation, okay, if you want, I will give in Telugu. Okay. So that's what. Understood, right? This is vertical configuration. So this bottom most one will be near to the ground. Okay, so this is the ground, and this will be little bit more distance. This will be little bit more distance from the ground. Okay, so that means when distance is changing, you may know the capacitance formula, right? C equal to epsilon A divided by D. When distance changes, then automatically capacitance changes. That means for A phase different capacitance, for B phase different capacitance, for C phase different capacitance. That's why what you need to know, every phase don't have the same capacitance, same inductance. See, every phase don't have the same capacitance and same inductance. Then you need to analyze A phase separately, B phase separately, and C phase separately. You understood, right? You understood, right? Separate analysis we need to do. It will take more and more time. Not only one transmission line, 11 kV transmission line same, 33 kV transmission line same, and 220 kV transmission line same, like 400 kV, everything. Okay, 765 kV you have to analyze same, 1000 kV you have to analyze same. It's difficult. Okay, so that much data you have to manage, and that many phases you need to understand. Why to do that? I will represent as per phase model. That means for all the three phases, I will represent as a single phase model. Okay, so per phase model you will understand. What is this per phase model means? It will be valid for A phase, it will be valid for B phase also, it will be valid for C phase also. Okay, so let's represent for every transmission line, there will be some resistance, there will be some inductance, and there will be some capacitance. Okay, so like this, from the sending end to the receiving end. Okay, so this is nothing but sending end. Okay, and this is nothing but receiving end. Okay, so receiving end. Understood, right? So this is R per phase. Okay, so R per phase means we need to calculate this one per phase value, and we have to give. This is nothing but L per phase, and this is nothing but C per phase. Okay, so like this, everything you have to represent for the transmission line. Okay, R, L, and C. Okay, so the transmission line can be represented as RL model, RLC model, or RLCG model. Okay, so G means conductance parameter. Okay, so RL model or RLC model, RLCG model. So based on whether that is short transmission line, medium transmission line, or long line, based on that you will understand. Okay, if the length of the transmission line is less than 80 km, then you will consider that as the short transmission line. If the length is between 80 to 160, then we will consider as medium transmission line. If the length is greater than 160 km, then you will consider as long line. Okay, so and if short line means you have to represent as RL model, medium line means RLC model, long line means RLCG model. So in other concepts you will understand this all. Okay, so see one thing. So as for every phase, inductance and capacitance calculations are not same, but resistance will be same. How resistance can be calculated? R equal to rho L divided by A. Whether this is for A phase, B phase, or C phase, for every phase it is. You observe what is this rho? Resistivity of the conductor. Resistivity. What is the material? Aluminum material. This is also aluminum material. This is also aluminum material. That means for every phase the resistance is same only. Okay, for every phase resistivity is same only. Length of the transmission line, okay, so from the sending end to the receiving end side, okay, so length, first transmission line 100 km, second transmission line 101 km, not possible, right? Okay, 100 km only, okay, first transmission line 100 kilometers, second transmission line also 100 kilometers only. You understood, right? And other one also 100 kilometers only. That means length is also same for all the three phases. And area of cross section, is that same for all the three phases? That is same. Understood, right? Because current in all the three phases is same. So radius, otherwise area of cross section of the conductors is also same for each and every phase. Okay, you understood, right? Okay, so that's why resistance for A phase, resistance for B phase and resistance for C phase, everything is same only, but inductance per phase and capacitance per phase for all the phases, okay, A phase, B phase, C phase, it will be different. Once it will be different, then you cannot analyze even a single network, okay, A separately, B separately, C separately, we have to do. Instead of that, we are representing a per phase model. To represent like that, see, mutual distances are different. Understood, right? Mutual distances are different. So that means distances are different. From the conductor to conductor, distances are different, and from conductor to the ground, distances are different. That's why what you will calculate is, instead of doing direct distance calculations, you will calculate GMD, geometric mean distance, and geometric mean radius calculations. Okay, understand why we are doing GMD and GMR calculations? To represent the network in per phase model. Okay, to represent the transmission line network in per phase model. Understanding, right? Once you represent like this, so that means you need to know L per phase separately, you need to know C per phase separately, including all the three phases. Okay, how you can do that? Calculate GMD and GMR, then you can represent like this. You are understanding, right? We have to calculate like GMD and GMR, then only you can get the points. Okay, so that's what you got it, right? Importance of GMD and GMR, we need to represent per phase and per phase model. That's why we are just representing GMR and GMDs. Okay, so that's all. Anyway, you just see, if this is the three phase system, which is A phase, B phase and C phase, this is the radius R and this is the radius R and this is the radius R. Okay, because all the three phases are balanced now. Okay, so balanced current only you will be preferring. I at an angle of 0, I at an angle of minus 120, I at an angle of minus 240. Okay, so these are the three currents. And anyway, distance between the conductors. Okay, let's take from center to center only. Okay, so that is the distance you will be considering. Okay, this distance is nothing but X we will consider, this distance is nothing but Y we consider, and this distance is nothing but Z we consider. Okay, understanding, right? So these are the all the three conductors we have, which are separated at a distance, okay, X, Y and Z only. Okay, so now you see there will be flux linkages on this one, but entire conductor you will not get the flux linkages, there will be skin effect, right? We can understand some of the linkages will not be getting, that's why all the current. So what is the skin effect? If you just want to know, so skin effect means, so the ability of AC current which is flowing near to the surface of the conductor, that is nothing but skin effect, we can understand. Okay, so anyway, the radius of this one is R only, but effective radius is nothing but R. It is not directly R, so R into 0.7788. Okay, so like that 0.7788 into R. Okay, so which is nothing but geometric mean radius. You observe, entire radius you will not be getting the flux linkages. Okay, only up to certain radius only we are getting, that is nothing but 0.7788 into R. Okay, so that is nothing but geometric mean radius. Okay, and similarly geometric mean distance, geometric mean distance means GMD we have to calculate. What is GMD means? So let's calculate for GMD, okay, of A phase. Okay, so GMD of A phase we will calculate. that means mutual distances, okay. GMR means self linkages, GMD means mutual linkages, okay. So what are the mutual linkages? Based on the distance they will be right, okay. So that's why GMD of A means A to B, how much distance? X distance is there, and A to C, how much distance? Z distance is there, okay. You may write down as X plus Y, let's write down as Y, Z only, okay. So X into Z, how many terms are there? 2 terms are there, so to whole power 1 by 2. Got it right? This is GMD, okay. So why we have taken this whole power 1 by 2? 2 terms are there, that's why we have to take down as whole power 1 by 2, okay. For example, one more conductor is there, fourth conductor. First distance X, second distance Z, and other distance, if it is some X, some other value is there, then we have to give that value, and whole power 1 by 3 we have to give, okay. Now similarly, GMD of B, for the B phase, okay, you just calculate from here to here, what is the distance? X, because this mutual linkage of B phase, it will link with A phase definitely, and mutual linkage of B phase, it may link with C phase also. Understanding right? Okay. So that means X is the distance from here to here, Y is the distance from here to here, X into Y whole power 1 by 2. Understanding right? X into Y whole power 1 by 2. Okay. So now next one, GMD of C, if you want to calculate from the C to B, what is the distance? Y. From the C to A, what is the distance? Z. Okay. So C into, not C, so that is Y into Z whole power 1 by 2. This is GMD of A phase only, this is GMD of B phase only, this is GMD of C phase only. Now if you want GMD of system, okay, so GMD of system you want to calculate. What is the GMD of entire system? Why we are calculating GMD of entire system? Because for the entire system you need to represent per phase model, okay. So per phase model you need to represent, that's why GMD of entire system is equal to GMD of A into GMD of B into GMD of C whole power, how many terms are there? 1, 2, 3, okay. So whole power 1 by 3 we have to use like that. Understanding right? So GMD of A into GMD of B into GMD of C. Now let's calculate, this is GMD of entire system, okay. Now similarly GMR also will calculate, okay. So GMR of A, that means for A phase, what are the self linkages? GMR means self linkages, GMD means mutual linkages, okay. GMR of A means for A phase, how much linkage you can get? Up to a radius of 0.7788 into R only, otherwise we can call as R dash directly, okay. We can call as R dash, okay. And similarly, so for the B phase also it will be same, right? For the B phase also it will be same, radius is same, so definitely mutual link, self linkage will be 0.7788 into R, okay. So that will be R dash. Now similarly for the GMR of C phase also 0.7788 into R, okay. So that will be equal to R dash, okay. But if you want to do separate analysis, these we will calculate separately, but if you want to represent for the entire system, then you have to calculate entire system GMR, entire system GMD, okay. Because we want to represent as a per phase model, as a single model we have to represent, not A phase separately, not B phase separately, not C phase separately. We have to represent as a constant normal normal per phase model you have to represent. That's why GMR of system, how we can represent? So that will be equal to GMR of A phase into GMR of B phase into GMR of C phase whole power 1 by how many terms? 3 terms are there, okay. So total it will be whole power 1 by 3. These are GMD and GMR calculation. See one thing, so this is only one concept, one basic concept, and not only for this type of model, okay. So let's take vertical configuration. For this also you have to calculate. Let's take symmetrical configuration. What is symmetrical configuration? Symmetrical configuration means first conductor will be here, second conductor will be here, and third conductor will be here. Distance between these two is same. Distance between these two and distance between these two, everything will be same. So that is symmetrical configuration. This is unsymmetrical configuration. This is also unsymmetrical configuration. These all comes in the three-phase system only. Okay, so these all in the three-phase only. Single phase also we can do. Okay, so single phase two-wire system. What is single phase two-wire? One will be phase wire, another one will be neutral wire. Between these two some distance will be there. Okay, for everything no need to do phase analysis separate and neutral analysis separate. For everything a per phase model will represent. Okay, whether that is so three phase asymmetrical configuration or three phase symmetrical configuration. Okay, whether that is horizontal configuration or vertical configuration, for everything you need to represent per phase model. Okay, so that's how you can make. Okay, so this is all about GMD and GMR calculations only. So anyway, if you want to know about some more points, you can ask me now. Okay, so I will be explaining those things to you. Okay, so I will be explaining those things to you. You can ask me in 5 minutes. Okay, so I will explain. Okay, so what you want to know more about the power systems, you can ask me. So this is only very less concept we have discussed now. Okay, and we have to study effectively. Remember one thing, for entire power system, if you know about previous year concepts. Okay, so I am not telling you like previous year bits. Okay, we are not discussing previous year bits, previous year concepts. Okay, so whatever concepts they were giving, we need to know about those bits. So then those concepts we need to know, then we can answer properly. Okay, so power system, so many of you may think, okay, so it is a very big subject, we have to study more for that, many days we have to prepare, like 2 months continuously I have to prepare. Not like that. Okay, spend some 10 to 15 days. Okay, that's enough if you study properly. Okay, just like at least of 7 to 8 hours or more than that. Okay, if you study means how you will study. Okay, so properly whenever you are watching some video of power system classes, otherwise if you are preparing some textbook, you need to write down everything. Okay, so from that you can understand. And remember one thing, power system you have to study in order. Okay, first I will study economic load dispatch, for example. Okay, economic load dispatch means whenever different generators are there. Okay, I have our load center. Okay, so I need more power, like 500 megawatt I need, but this generator can give up to 1000 megawatts, and this generator, another generator can give up to 500 megawatt, but one is near for us. Okay, so we have to share the load between these two generators according to the economic load dispatch. Okay, so but to understand this economic load dispatch, you need to know about how the generation will be fixed, what is the plant capacity, how the generation, this is the hydroelectric power station or peak load power plant or base load power plant, these all concepts you need to know. So that's why power system, if you do per unit analysis, so representation of transformer is like this. Okay, so I will tell you, representation of transformer is like this in a single line model, I will tell you. So that means transformer concept you might have no, right? Definitely. Okay, we have to assume like that. Why to do all those things? Okay, so whenever you are studying power system, study from the order. Okay, order means generation, later transmission distribution, later power system analysis. Then once you did the analysis, then you do the production concept. Understood, right? Production concept I have not given there completely. So this is the order. Okay, in this order you prepare, and even the bits also. Okay, so while you are doing the previous year bits, do in this order only, then it will be more useful for you. Okay, so you will never forget power system, every concept. What is the corona? Okay, electrical corona, how it will happen in the transmission lines. Only 15 minutes if you spend time properly, then you will definitely understand and will never forget that. What is skin effect? What is proximity effect? What is Ferranti effect? See, these 4 effects if you know, Ferranti effect, proximity effect, skin effect, corona effect. So these four, if you know, so you may know already why to tell this. So definitely 1 or 2 bits will be there from these 4 bits, from these 4 concepts only. You understood, right? And there is some sag effect also, okay? So these are the basic things. And there are some types of conductors. We have solid conductors, stranded conductors, composite stranded conductors, and we have hollow conductor system. And why we are using all these types? We have bundled conductor system also. Why we are using, okay? So in our last session I have explained about all these types of conductors. If you want, you can watch even that also. And otherwise you will get to know, okay, so how much deep this power system is, okay? So whenever you feel uncomfortable with the power systems, you can even ask us so later, okay? Understanding, right? So that's what about today's session, okay? So you can ask something if you want any preparation strategies or any power system concept if you want to know, or if you have any doubts, you can ask me now. So otherwise we will be winding up this, okay? Understood, right? So you can ask me something, okay? So you can ask in Telugu, okay? Telugulo maatladagalanu, there is no problem, okay? Yeah, for power system, not only for power systems, okay? So even for the machines, so complete DC machines, synchronous machines, induction machines and transformer concept, you can study however you are comfortable, these all 4 machines, but do the bits properly, okay? So previous year bits you have to do properly, okay? So that's what you need to do. Understood, right? So previous year bits are very important, not only for your exam AE or AEE, you go for GATE exam, okay? So for GATE exam also, if you do the previous year questions, so 1 or 2 times, okay? So like 10 or 15 years of previous year bits if you do, then you can score more, okay? So like almost 50 to 60% of the marks, they will be decided based on the previous year concepts only, okay? I am telling you, previous year concepts only. Understood, right? Okay, so that's what. And even for SSC junior engineer exam or RRB junior engineer exam or any state level exams, okay? So even for Karnataka Transco exams also there, okay? You can apply all those things. Power system concepts are definitely required in every exam, okay? Wherever you have electrical power systems, okay? So there are definitely many questions they will ask. And you may know or not, I am just telling you, in Telugu states the competition is little bit higher when compared to other states. That's why just be safe, okay? Like concepts like power systems you should not leave, okay? Circuits everyone will do. If for example 20 questions will come, almost 16 to 17 questions everyone will do, okay? Don't leave the 3 questions also. But power systems, you know, right? So some people will get fear about these power systems. Why means they will not study in order, okay? Once you have not studied in order, definitely everything you will forget, okay? Remember, so study about generation concept, do the previous year bits, okay? Next, do the transmission concepts, and after that do the bits, okay? So after that you need to know about analysis, power system analysis, then complete the previous year bits, okay? If you are preparing for any exam, okay, so that exam previous year bits you have to complete, okay? Understanding, right? So protection also same like that, okay? So in many exams actually protection concepts they are giving very less only, but if you go for some interviews, okay, protection concepts they will definitely ask you, okay? So that's why protection concepts you should never, okay? So contact between synchronous and induction, contest between clarity in the subject, okay? So that's what, okay? So more topics I need to know, more topics you need to know, more topics of what? Power systems. So just ask again, okay? I will tell you, which means Clarity in the subject. Okay. Yeah, clarity in the subject only. Okay, so you need more clarity in the subject. So generally, which subjects you will get the clarity, you know? So subjects like networks, you will get more clarity. Control systems, you will get more clarity. Okay, signals and systems also you can get clarity. Digitals also you will get clarity. Why means in order we will follow. Okay, you just see the network concept. How you will study? You will study about node, branch. One by one we will study later nodal analysis, mesh analysis, resistance reduction technique, star to delta transformation, delta to star. Slowly we will enter into our theorems, okay? So Thevenin's theorem, Norton's theorem, these all we will be understanding. Later you will know about different AC circuit analysis. Later transient. You study transient at the beginning, okay? Can you understand completely? It's not possible, right? Okay, so we can understand that. Okay, that's the form in order. Okay, but the power systems, so based on the lecturer, if you follow that may advantage for you, that may be advantage for you, may not be advantage sometimes, but prepare in order. Okay, like do the previous year bits. Okay, never leave previous year bits, not only from power systems. Okay, in every other subject also complete all previous year bits. You will definitely score more. Okay, you will get more confidence also while solving only you will know. Okay, so you will get more confidence about all those things. Okay, so that's what difference between synchronous and induction motor. Okay, so difference between induction and synchronous motor means the synchronous speed. Okay, so induction machine, like it will be, if it is more speed, okay, so then it will be a generator. Less speed means it will be, so it is motor. Okay, so like that, you understood, right? And similarly, so for the synchronous motor, okay, synchronous generator or motor, so it will be constant speed rotors. Okay, so actually there are many other concepts also we have to explain for this. So maybe in some other live, okay, so there will be the concept difference between synchronous and induction machines. Okay, you will get that point. Okay, so may not be from this, so you can ask some power systems also. Okay, so basic point I have just given about machines, but even more deeper you need to understand. Okay, so yes, power system, yeah. Okay, in power system you want to know. Okay, so just more concepts you need. Okay, whatever concept names I have given right at the beginning. Okay, so if you want, you can backward the video and just observe. At the beginning I have given many concepts. Okay, many concepts, everything is one concept only. Okay, and like in generating stations we have components. Okay, dam is some component, reservoir is some component, spillways is some component, trash track is some component, and we have many other, like tunnel is some component, penstock is some component. After that we have surge tank. Okay, surge tank, after that penstock, after that nozzle, turbine, which type of turbines we are using. If this is a water turbine, okay, that means if this is hydroelectric power plant, so there are different types of turbines we are using. Then machine we are using, which type of machine we can use. Then which type of power supply we are just preferring. One by one. Okay, I'm just explaining you complete operation of hydroelectric power station. So topic name only I have given, hydroelectric power station. In there many concepts are there, one by one, step by step. If you see, everything you will understand. Okay, so I have given the idea how to understand one concept completely. Okay, in power system, never leave. Okay, in order only I have just explained. Will stop the water, construct the dam, stop the water, reservoir will form. In that reservoir, whatever water is present, if you need power supply, then trash track will be there. Trash track means our mesh. Okay, like the టీ మనం వడగొడతాం కదా, అట్లా వాటర్లో ఉన్న స్టోన్స్ ఇవన్నీ కూడా రాకుండా స్టాప్ చేస్తుంది దానికి. ఓకే, సో దట్ ఈస్ ట్రాష్ ట్రాక్. ఓకే, ట్రాష్ ట్రాక్లోంచి ఇట్ ఈస్ జస్ట్ లైక్ ఐరన్ మెష్. ఓకే, ఐరన్ మెష్ ఇట్ ఈస్. ఓకే, so cloths or stones or any debris, they will not enter into the tunnel. Okay, if those all enter into the tunnel, it will hit the turbine buckets, and turbine buckets will damage everything, we need to change. Okay, so that's why trash track required. Okay, after that water will enter into the spillways, then after that penstock it will reach, then from the nozzle it will hit on the turbine blades or buckets. Okay, so some of the turbines have blades, some of the turbines have buckets. Okay, so then it will be rotating turbine, and then shaft of the turbine will be connected to the generator, same shaft. Okay, so then definitely generator rotor will be rotated, and with that generation possible. Okay, so that is what power generation. Okay, our water energy, hydro energy to electrical energy will be converting. Okay, so that's what understanding, right? One concept only I have just given, but everything we need to know like that only. Okay, so that's why power system concept in order only we need to study. Okay, you will never forget. Okay, in order you need to understand that. Understood, right? Yeah, thank you so much everyone. If you want to ask anything, okay, you can comment in this one, and in next lives also we'll be discussing about some more concepts also. Okay, so that's what. Thank you so much everyone.